So yesterday we did almost all of 2-3. I did finish 2-3 on that first video. So if somebody is home and watching this, so like Sophia, who else is there? Bianca, and Jenny. If you're watching this at home, the end of 2-3 is on yesterday's. I'm not going to put it on this video. This video is just going to cover 2-3. Okay. All right. So 2-3, the parts that we did cover on this warm up. The first one is divide. Okay, and this is obviously can't be done synthetically. Why? X is squared, so you can only do synthetic if x, what you're dividing by, right, is raised to the first power. So I'm going to zoom that out. I'm going to do long division. I'm going to do x to the fourth minus 2x to the third plus x squared plus 2x minus 8. I have a term for every term from the highest exponent down to none, and they are already in order, so I don't have to rearrange or plug in any placeholders. What I'm dividing by, however, is x squared minus 3, which is missing your 0x. So I'm going to plug that in. So x squared plus 0x minus 3. If you don't do that, hopefully you get hung up at some point because your x's won't line up. Like you're trying to combine like an x to the third with an x to the second, and that's where hopefully you'll catch it and realize you have to alter it. So whether it's on the outside or the inside, they both have to be in decreasing degree order, and you need a term for every term from the highest exponent down to the constant. All right, so then I would say, look at the first here and the first here. What would I multiply x squared to get to x to the fourth? X squared, multiply it out, I get x to the fourth. And I can do a plus or a minus 0, it doesn't matter. 0x to the third, okay, minus 3x squared. And then I'll change my signs and add these. These cancel. Negative 2 minus 0 doesn't matter, it's still negative 2x to the third. And then 1x squared plus 3x squared is 4x squared. And then I bring down the next one, which is positive 2x. And then repeat that process again. So what would I have to multiply? X squared to get to negative 2x to the third. Say again? Minus 2x, good. And then distribute that to all three of them. So negative 2x to the third plus or minus 0x squared plus 6x. Change your signs. Or this is a minus. Cancels. 4x squared minus 4x. Bring down the negative 8. Repeat that process again. So to get to 4x squared, I'd have to multiply by positive 4, right? Distribute that to all three of them. 4x squared plus 0x minus 12. Last step, change your signs and add, cancels, negative 4x plus 4. Yep.
Okay, when you multiplied like the negative 2, because you're subtracting it and then it's a negative, wouldn't you add it?
For which one?
For negative 2x times like the 0.
Right, so this one here is a negative, that's a negative. And then I multiplied the negative 2x times the x to the third, x to the second, and I got negative 2x to the second. And then negative, I changed it, right, and then added, and it was a negative and a positive, so they cancel out. So the teal was a negative 2x to the third, and then I changed it to positive. And the black was always negative 2x to the third, so when those add, those cancel out. All right, so when I write my answer, I would write it as x squared minus 2x plus 4. Normally, I put a plus in between the negative 4x plus 4 would go over x squared minus 3. But if there's a negative in the top, and watch this happen because this is going to confuse some people. If there's a negative in the top, so if that first term here is negative, then I'm going to change the sign in between these to a minus. But you're taking out a negative 1 here. So when I put a minus here, it changes the 4x to be positive, and it changes the 4 to be negative. So when I separate it out by that minus, that negative comes out of both terms in my numerator if I have more than one term.
Do you have to do that?
Yes. So you'll always separate it out. If it's positive, you don't have to change it. If it's negative, you're pulling out a negative 1. The minus goes in between, and then the signs would change. If there's only one term, you just pull off the minus. But if there's 2 terms in the top, or 3 terms, it's going to impact both those terms. Okay, number 2, use synthetic division and the remainder theorem to find the value of f of 2. So the directions tell you what you're supposed to be doing here. Synthetic division puts the 2 on the outside. I go in order from highest degree down to none. There's nothing missing, so I write the coefficients. 1, 1, negative 11, and 10. Synthetic division pulls down the 1, multiply it by 2, put it in the next column, add it, multiply it, put it in the next column, add it, multiply it, put it in the next column, add it. My remainder here is my answer. So f of 2 would equal 0. You can either write it that way or just give me the 0, but you're not writing your whole coefficient. Write your whole quotient, sorry. Because this one says find the value of f of 2. So when you're using the remainder theorem, you're finding the value by just either plugging in the 2, right? Would just be if it said f of 2, but because it says use synthetic division and the remainder theorem, you know to do it this way. Okay, and then 3 says using f of x equals x to the third plus 3x squared minus 4x minus 12. Find A, possible roots, B, actual roots. So remember, possible are plus and minus the factors of the last over the factors of the first. So the first is just 1. The last would be 1 and 12. 2 and 6, yep.
Could they give you the equation but put everything out of the correct order?
Sure.
And
Great question. Would it always be in order? No.
But
You always want to put it in decreasing degree order.
So, okay.
Yep. Everybody heard that? So if that said 3x to the second plus x to the third, the first is still the x to the third. You got to put it in order first, okay? All right, so then I'm over 1 this time, so it's still just plus and minus 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 12 over 1. Okay, but yesterday we also talked about if there was a number on the front of that x to the third, let's say there's 2 there, then I have to put all those numbers over 1, and I have to put all those numbers over 2. All right, so now I'm going to figure out what the actual roots are. So if I start by starting with 1, actually let's cheat. Who got 1? For time's sake. 2. Okay, I'm going to go straight to 2. I would have, again, had time. I would have done 1, negative 1, and then I would have gone to 2. Bring down the 1, 2, 5, 10, 6, 12, 0. And I would have known that if this is 0, that my first root is 2. And then use this function, the quotient, to factor it. So x plus 3 and x plus 2, and then solve it. Negative 3, negative 2, and those are my additional zeros. Remember, all of them count. Maya. On your test, and I'll tell you right now that this question is going to come up on the section in which you have a graphing calculator. It's going to have you graph it to find one of the roots, and then you'll put that on the outside, decrease it a degree. And then you'll find the additional roots. So they won't be all whole numbers, and they won't be easy to read from the graph. So you've got to make sure you would be able to identify one of them. First, you're going to list all the possibles. Identify one of them from the graph, and then find the additional ones by factoring or solving. Yep.